Hey everybody, welcome back to another fun and exciting pre-algebra class. Today we'll be in lesson 8.6 talking about dependent events, and that's going to be on page 393 is where that starts. Page 393, lesson 8.6, dependent events. So what is a dependent event? Well, if you say, well, that depends, you are correct. What does it depend on? Let's talk about that. Notice here in your book, or you can look down at the screen, says that dependent events are events where the outcome of one event influences the outcome of the other event. So something like, whatever happened in the first event, then that makes that not possible in the second event. Something like that. Here's an example. We've been talking about the jars and the marbles and, the blue ones and the red ones, right? Okay, I know you're probably tired of that example by now, but it's the easiest way to kind of tie all these things together. So we have our jar, and we have our 5 red marbles, we have our 2 blue marbles, and we have our 3 yellow marbles. What is the probability of selecting 2 blue marbles in a row if you do not replace the first marble? So here is why it's dependent. When you pull out the first blue marble, you put it away, you put it on the table. You're like, okay, I'm done with that one. In the other ones, we've been taking, for instance, we've been taking the blue marble out, and then we put it back in before the second event. So that doesn't really change. That's called independent, because that first one doesn't change the possibilities for the second one. But now if we take that blue marble and we leave it outside, we put it on the table, okay? Now it changes what might happen in the second event. Take a look down here at what I wrote. The formula is the same as independent events. So the probability of A times the probability of B. The only difference being that you have a new total for the B event. All right, let's go back and do that real quick. Let's run through this example with that kind of in our minds. So we're looking for a blue marble. So let's do the first event. So event A. Event A is selecting 1 blue marble. So we have to take each event separately. Okay, so the first event is selecting a blue marble. Before we can get a second blue marble, we have to get the first one. So we would have a 1 over, and there's 10 marbles, 1 over 10, right? No, hold on a second. There's 2 blue marbles. So we're going to have a 2 out of 10 chance, okay? Because there's 2 blue marbles in there. Now remember, we're taking the blue marble and we're leaving it outside. We're putting it on the desk. Now, that is event A. We'll call this event A down here. And then we're going to multiply by event B. What is event B? Another blue marble. Okay, so now when we go back to the jar, we put our hand in the jar, how many marbles total are in there? That's right, there's 9 marbles. Why? Because we took one of the blue ones out. There was 10, but we took a blue one out. Now there's 9. So look, our new total marbles is going to be 9 because we put one on the desk. How many total blue marbles are in there? That's right, there's only 1 this time because we took one of the blue marbles out. It's on the desk. It's not in the jar anymore. So our probability in event A is 2 over 10. Why? Because there's 2 blue marbles, 10 total marbles. We take that blue marble out, we put it on the table. Now we do event B. Now there's only 1 blue marble left in the box, or in the jar, and there are only 9 total marbles left in the jar. So we would just now multiply. So again, we do it the same as we did with independent events, but the difference is this B event is going to be changing based on the first event, okay? So let's just multiply that. So we get 2 times 1 is going to be 2, and then 10 times 9 is going to be 90. we would need to reduce that. 2 goes into 2 one time. 2 goes into 90. That goes 45 times. So your answer would be 1 over 45. Now you could grab your calculator and you could go ahead and divide that. So we do 1 divided by 45 equals 0.022222, so 0.02, or you could do 2%. There's only a 2% chance that that's actually going to happen. Okay? Note, typically when you get into dependent events, you get a very, very small possibility of that actually happening. Why? Because you continue to lower your odds of the second event happening, because the first event has to happen, and then that changes the odds for the second event. So, you shouldn't be getting like 80% chance that that's going to happen. Typically in dependent events, it's going to be a small number of a possibility of something actually happening in that order. Next, let's go ahead and look at the example in the book on page 394. Page 394 says, a fish tank contains 9 clownfish, 3 crabs, 7 pufferfish, and 2 starfish. The tank is being cleaned, and the fish are being removed one by one randomly. So it's not like they're like, okay, let's take out all the clownfish first, and then let's take out all the crabs next, and then let's take all the pufferfish out. No. It's scoop in there and whatever comes out. So here's question A. This is what they're asking right here. What is the probability that a pufferfish will be removed first, followed by a crab? Okay. So let's, first of all, the A event is the pufferfish. The B event is the crab. Okay. So we have to do, it's going to be the probability of A times the probability of B. That's going to be our formula that we're looking for. And so what is the probability of a pufferfish? Well, there are 7 pufferfish. So we would have 7 over, I don't know, we haven't added these up yet. We need to know how many total fish there are. So let's see, 7 and 3, there's 10, there's 9 of the clownfish, that's 19. And so we have 21 total fish in the tank. So 7 over 21 times the B event. Now, think about this. One of the pufferfish, one of them, has been removed. This is a dependent event because now B depends on A happening. So now we've removed a pufferfish. So now how many total fish are in the tank? Well, there's 20 total fish in the tank. I know crabs aren't fish, okay? You don't have to report me to your biology teacher. I already know that, okay? So you guys think you're smarter than me. Well, probably you are, but I do know that crabs are not fish, okay? And technically starfish are not fish either, okay? So I know some of you are like, come on, Mr. Steve, starfish aren't fish either. I know, all right? So, you're like, what is going on right now? I thought this was math class. No, it's become biology class, marine biology class really quickly. All right, but let's go back to the problem. So we took one fish out. That fish was a pufferfish, okay? How many fish are in there now? There are 20 total fish, marine animals. Okay, there you go. So how many are crabs? Well, there are 3 crabs still in there. So we would have that right there. Now we would just reduce where we can reduce, and unfortunately there's not a whole lot of reducing that can happen. We can do just one little reduction here, and that would reduce to a 7, so then we're going to get 7 over, what is that, 140, I guess. All right, and then maybe we could reduce, actually we can reduce again. Check this out. We could just reduce, because some of you, we're like, why didn't you reduce that, Mr. Steve? I don't know. I just didn't. But I should have, right? So there we go. I reduced those 7s, and you can do that. You can reduce up and down before you multiply. Some of you thought you could just do cross reduction, but you can reduce the fraction up and down as well. So we have 1 times 1, it's 1, and we have 1 times 20 is 20. So there would be a 1 in 20 chance of that happening. Then you would go to your calculator. You could divide that out. So 1 divided by 20 equals 0.05. So 0.05 would be our decimal, and then 5% chance would be our percent. All right, letter B. What is the probability that the first 3 to be removed are all crabs? Well, let's go back to this and let's find out. Remember, we had 21 total. So the first one would be for event A, that's a crab. Event B is another crab, and event C is a third crab. Because remember, we had to get 3 in a row, all crabs. So the first one, we're going to have 3 over 21, because there's 21 total fish in the tank. So 3 over 21. And then the next one is going to be, now we've taken out a crab, so we have 2 left. We've taken out one of the total, so now we have 20. And then we do it again, so now we have 1 crab and we have 19 total marine animals in the tank. All right, so let's go ahead and reduce where we can reduce. So this one reduces to 1 and 7. This one reduces to 1 and 10. And so we have 1 times 1 times 1. That's going to equal 1. And in the bottom, we have 7 times 10. That's 70 times 19. I don't know 19 times 70. 19 times 70 equals 1,330. So that's not a very good chance of that happening right there. You'd probably just want to leave that in a fraction. You could put that in a decimal, but it's going to be a big decimal number. So probably just in a fraction is fine right there. All right. And then the next one, the last one that we'll do for this lesson, and this is going to be another fast lesson. Aren't you proud of me? I'm learning so much. I'm learning how to do shorter videos, and I know you're proud. Letter C. What is the probability that neither of the first 2 fish to be removed are clownfish? All right, so this one we got to think a little bit. So what is event A? Event A is anything but clownfish. And then event B is also anything but clownfish. Okay, so event A times event B. Now, how many total fish are there? There are 21 total fish. So how many of them are not clownfish? Well, there are 9 total clownfish. So you do 21 minus 9, and you would get 12. So 12 of them are not clownfish. Now, think about this. Now we've removed one, not a clownfish. So there are now 20 total fish. Remember, we did not remove a clownfish. So look, there are still 9 clownfish in the tank. And so now we would just subtract 20 and 9, and we would get 11. So now there's 11. So that's how you would do that one. You could cross-reduce this right here. That goes in there. See, 2 goes in there 6 times. 2 goes in there 10. No, we can reduce that again. So that would be 3 and 5. And then you could cancel right there. So you could 3 goes in 21 7 times. So you'd have 1 times 11, that equals 11. And 7 times 5 is 35. 11 over 35 would be your probability of the first 2 fish not being a clownfish. Okay. All right. Well, hopefully you kind of are putting some of this together. I mean, we've been doing this now for, I think, 4 or 5 lessons. So hopefully this is kind of starting to click in and make sense. Really, the hard part here is not the math. The hard part is kind of the words, making sure you understand what they're asking for. Make sure you remember, okay, what formula do I use? If you look in your book on page 395, there's a little example there, a little chart, little table that you can look at, and it tells you for any compound event. So if they're mutually exclusive, if they're not mutually exclusive, which we didn't really talk about too much, and you won't probably have any of that on your quiz or test, but it's there in your book if you need to see it. And then it talks about independent and dependent events. So let's real quick kind of recap that. With mutually exclusive, that's the one that has the word or in there. So if you see the word or in probability, remember you're going to add. So or means add. And then you have the independent and dependent events. The formula is the same. Here's what you do. Take event A and multiply it by event B. What if you have a C event? Then you multiply by C. D, E, however many events you have, you keep going. Now, what's the difference between independent and dependent? Here's the difference. In independent events, the first one does not affect the second one. So, in other words, you are putting the marble back into the jar. On dependent events, you're taking the marble out of the jar. The second event changes because you took a marble out of the jar. You did not replace it. It's kind of the concept there, and that works with taking fish out of a tank. That works with a number of different things. So anytime that you change the second event, when you take something out of the equation, then you're now dealing with dependent events. Okay? And so what's the difference is you would just change your equation, your fraction on the dependent event, and then but you still multiply and then just reduce, and that's going to give you your probability from there. Okay? That's all I got for you. Try some of these. Practice. Okay? Go to your book and do some of these and see how you do trying to figure out, okay, is this mutually exclusive? Is this independent? What is this dependent? What's going on here? So try to, take these one by one, figure them out, and work the formula to get your answers. Okay? That's all I got for you. We'll see you later. Have a good one. Bye-bye.